Hi everyone, welcome back to Carpe Diem Sailing. If you're new to the channel, my name's Marco, I'm a Sail Canada cruising instructor, and in today's video I'll be doing an intro to basic plotting. Welcome to episode 37, Basic Plotting Part 1. For show notes and helpful checklists, please go to www.carpediemsailing.com/shownotes. I have included a link in the description below. And now, let's get started.
Here we see an assortment of tools that are used in coastal navigation. We have the traditional parallel rules, we have dividers, a pencil, an eraser, a timepiece, a notebook, and then a protractor. So I'm just going to talk about each of these now individually. We're going to start with the parallel rules. So parallel rules have long been a traditional method for measuring courses. So let's say I want to sail from the narrows here out into the bay, and I want to determine what that course is so that I can determine a course to steer. So what I do is I take my parallel rules, and you'll see that there are these compass roses that are printed on the chart. And what I do is walk the parallel rules over to the center of the chart, and then looking at the direction of my travel, which is now from east to west, I read the direction, or the bearing, which is 267, 268 degrees true. Now you'll see that there's this little ring inside here which are magnetic bearings, but those magnetic bearings were corrected for variation for 2000. So that was only accurate then. If you want to know how to use or how to convert magnetic bearings, check out my magnetic bearing video. So now that I have that, I would convert my bearing into a course to steer, and then I would steer that course. The downsides to these parallel rules, there's a couple of them. One is the chart has to be on a table big enough that you can spread it out so that you can have access to these compass roses. And two is that as you're walking your parallel rules up, they can slip. So if you're on a small boat moving at sea, you're even more there's more tendency to slip. So they are quite difficult to use. For me, I prefer using this plotter or protractor. So the way I would use this is take my direction of travel, so once again from the narrows out into the bay, and then I spin the protractor so that the grid on the protractor matches the grid on the chart with north at the top. So once I've done that, again looking at my direction of travel, so in this case moving to west, I read my direction right here. So we've got that course was 265, and then I would convert that true bearing into a compass or magnetic bearing as my course to steer. Dividers. So these dividers are actually quite handy because you can use them. They're basically one-handed dividers. Dividers are used to measure distance. And remember, whenever we measure distance on a Mercator's projection chart, we use the latitude scale along the edges of the chart. An accurate timepiece, either a watch like this with a sweep hand, or a digital clock, a phone, whatever. A good pencil and an eraser. So this is a commercial drawing pencil. It's a 2mm with a 2B lead. The 2B is softer than HB, so it's a little bit easier to erase. And then finally, what I call a navigator's notebook. So when you're taking bearings to determine positions, things like that, you can put them in your little notebook. A couple of other things that are useful, obviously a hand-bearing compass, a good pair of marine binoculars, and then obviously your ship's compass.
The term fixing means to determine your location through various means. The most common method is with the use of lines of position, or LOPs. In this example, I'm going to take a bearing to this lighthouse. This is what it looked like from the boat. I'll then convert that bearing from magnetic to true, and I'll plot it on the chart. Assuming I measured, converted, and plotted accurately, my position is somewhere along this line. To determine exactly where I am along this line, I need to shoot another bearing to another landmark. In this case, it will be the right-hand edge of this landmass, and this is what it looked like from the water. Where the second LOP bisects the first is my location. For the best accuracy, the second LOP should bisect as close to 90 degrees as possible. Ideally, I would plot a third LOP, and you will see this a bit later in the video. But for now, I just want you to understand what an LOP is. When it comes to labeling, there are some basic conventions, but depending on which book you read and whether you are in North America or Europe, there are some minor differences. I will go over them here. Here we see a 3 LOP fix. Each LOP is labeled with the time and the bearing. The fix is marked with a full circle with a dot in the center and the time and the word fix. Here is the same fix without the LOPs themselves being labeled, but we still see the circle and the time of the fix. The word fix is also omitted as it is obvious that this is a fix due to the intersection of the LOPs. This is my preferred method, as I find that it does not clutter the chart as much, and my bearings and times are noted in my navigator's notebook. A DR, or dead reckoning position, which is a predicted position based on course and speed, is marked with a semicircle and a time. They sometimes have a dot in the center, which is my preference, but I have also seen them marked with a semicircle and a slash, as you see here. Finally, I have one navigational reference that shows the DR labeled by only a slash and time and no semicircle. Fixes are known positions, and in addition to LOPs, there are various other ways of fixing a position, and they are labeled accordingly. We've already talked about the 3 LOP fix. A G-fix is a position determined by plotting latitude and longitude obtained from a GPS device. An R-fix is a running fix, which I will cover in Basic Plotting Part 2. Finally, we have the RA fix, which is a position determined by radar. Let's now take a look at a basic DR plot. So I went out a few days ago and tried a bit of an experiment, and I'm going to go through it right now with you guys. So what I did is I was actually sailing in this area here, and I wanted to get a fix using my 3 LOPs, and then I also got a GPS fix to confirm my position. So I looked for different landmarks in the area here that I could use to shoot my bearings for my LOPs. And then I went on a course of out this way here for about half an hour at 4 knots. So you'll see how the DR works. So what I'm gonna do is I'm going to plot my position. So I've got the numbers here from my hand bearing compasses, and I've got my positions here from my GPS. And then I'll show you a picture of the chart plotter as well. But what I did was I went out and shot these bearings. So I decided that I would use here the entrance to False Creek, the right-hand edge here of UBC, which is this land mass here, and then this lighthouse here at Point Atkinson. And what I've done is, as I was going in this direction, I picked the ones that are closest to my center line, because those are the ones that are going to change the least. So I picked those first. So the way I was driving out this way, this one seemed to be most closest to my center line. And the ones out to the sides, as you drive by, the bearing is actually going to change. So when you're shooting the bearings as you're moving along, shoot the ones closest to your front and back on your center line first, and then the ones out to the sides last, because those are the ones that are going to change the most. I hope that makes sense. So I've got a fix for 1559 and a fix for 1629, and then I've got 2 GPS fixes here. So the first thing I'm going to do is I'm going to plot my first fix, then we're going to plot our DR course, I'm going to plot my second fix, and then I'm going to plot my GPS fix, and we'll see how it all worked out. Wish me luck. So the first thing I've got is I shot a bearing to False Creek here of 113 magnetic. So with a current variation of 17 degrees east, using cadet compass to true, I add east, I get a true bearing of 130 degrees. So using my plotter, I go to the true index of 130 degrees, and then, as I mentioned earlier, what I want to do is rotate this so that this grid matches that grid and north is pointing to the top. And then what I do, making sure this doesn't slip, keeping it on 130, I orient it to those lines so that I'm lined up with those lines, but also lined up here with False Creek. So the entrance to False Creek, which is right about there. And then I draw my LOP, and what I do is I draw an arrowhead pointing away from it. I'm not going to bother with all the labeling right now. We're going to talk about that. We've talked about it before. I'm going to talk about it more in the video, but just to save time, there's my first LOP to False Creek, which is that one here. The second one, right-hand edge of UBC, 229 magnetic, 229 magnetic, plus 17 east variation gives me a true bearing of 246 degrees. So I go to 246 degrees on my true index, and once again, making sure that it doesn't slip, orienting north. I'm going to have to move this stuff out of the way for now. So again, orienting my grid, make sure it doesn't slip and move. Make sure that north is oriented to the meridians of longitude, and then I just move until I hit the edge of the land mass right there. And then my LOP is drawn from there in this direction, and those two cross. So that's where I should be. And they are crossing at 90 degrees, which is good. Now, ideally, I didn't shoot this one. I shot this one here. It looked like it might be enough of a divergence in angles, but you'll see it wasn't. So now that was Point Atkinson. So Point Atkinson is 283 plus 17 is 300 true. And you're going to see what I mean in a second here. So true, and I'm going to orient north again with these lines. Now, it's not quite long enough, so I'm going to have to guess a little bit at where that line is. So that's going to affect my accuracy a little bit. But I'm lined up, and then I draw my LOP from there out this way here. So you'll notice this triangle, and that triangle is called the cocked hat. So I should be anywhere in that zone. So ideally what I would do is I would pick this, if I was close to any dangers, I would pick the spot closest to the danger. But because these two lines, this one and that one, converge so closely, that's not very accurate. So this was not very good. So I'm just going to assume that I'm in the middle here, and I'm going to label my fix and the time of 1559. So now I want to project a course out here, and as it was, I followed a course of 262 degrees true, so I'm going to actually convert that. So using my compass plotting sheet, 262 degrees true, plus 17 east, or sorry, correction, minus 17 east, because I'm going from true to compass, gives me a magnetic bearing of 245. I do not have a deviation card for my boat, so I'm going to assume a compass bearing of 245. But that's what I'm going to steer, but I'm actually going to plot 262. So I go to 262, again, line up the north, take my spot, my fix, and then I'm going to draw my course line. So this is my course line. And so remember, the course line is a big arrow like that. The course is, I'm going to label it in magnetic because that's what we're actually steering, and my speed was 4 knots, so 4 nautical miles per hour. So I'm going to do another fix in half an hour, which means I now have to measure 2 nautical miles because that's half of 4. Using the latitude scale on the side of the chart, which you can't see right now, I'm going to measure 1 mile because this is quite a large scale chart. So there's 1 mile and there's 2 miles. So this is going to be my DR position, and I like the dot and the semicircle, and that's going to be half an hour from 1559. So it's going to be a DR of 1629. So assuming that this is correct and I was in this spot, if I follow this course for this amount, for this speed, that's where I should be. So then what I did is I drove for half an hour trying to steer 245 as accurately as possible, and then I took my second set of bearings. And the second set of bearings here, it was a little easier because I had a little more to work with. So there's actually a mark here, and it's on a big pole. So these buoys float. They can be used as aids, but they're not to be trusted because they do shift. But a fixed mark like this one will work. Again, I had the right-hand edge here of UBC, and I had the lighthouse here at Point Atkinson. So the order that I took them in, again, I'm moving in this direction. This one's closest to my center line. I shot that one first, I shot this one second, and I shot that one third. So the bearings that I ended up with were a bearing of 228 magnetic to this mark there, which I'm going to correct to 245 true. So 228 plus 17, 245
true. So once again, I go to my true index. I orient north with the grid, and I slide it up along until I am at my flashing light, and make sure that I'm oriented. And so far, this is looking pretty good, because that line of position puts me, I should be there on there somewhere. Now I want to confirm that with a few others, but right now that's looking good. So the next one I have is right hand edge of UBC, which is 204 plus 17, so 221 degrees. 221. Again, make sure that my north and the protractor doesn't slip and it stays on 221. I orient north to the grid, and I move it along until I come to the edge of UBC. And I draw my second LOP. And remember, little arrowheads pointing away from the LOP. And now this is looking pretty good. So my last one was 310 plus 17, 327. So I go to 327 degrees, and that's going to be off Little Point Atkinson Lighthouse once again. So 327, orient north up to the lighthouse, make sure I'm even with the grid here. The grid matches the grid. And I slide it along so I'm at the lighthouse. And you can see why GPS was invented, right? It's pretty laborious, and I'm not in a moving boat right now. So it is laborious, it takes a lot of time, but it does work reasonably well. So there is my fix. So I'm off by, according to my DR, so that would be my fix there for 1629. So right here you can see, yes, we might have some error, which does give us a little, room. You might be anywhere in there, but what this does is it increases your spatial awareness or your situational awareness, because you're not exact, you are keeping an eye out, because you have some errors. So it does make your situational awareness quite a bit more acute. You're keeping your eyes open. With GPS, I find people follow it so blindly that they do sometimes get into trouble. All right, so those are my fixes with the 3 LOP fixes. Now, what I did is I took my latitude and my longitude from my GPS. And I mentioned earlier that the parallel rules can come in handy for measuring latitude and longitude. So what I'm going to do on the side of the chart, I'm going to measure 49 degrees 17.9. So I find the closest printed line to the position, which is this one right here. And that line, you can't see it right now because it's off to the side, is 18 degrees. So I'm going to measure down from 18 degrees to 17.9. So it's only going to be 1/10 of a mile, so about 600 feet or so. And then what I do, so I use my dividers to measure down to 17.9. And I'm going to take my parallel rules to measure latitude. So 123 degrees, 11 minutes. So there's 123. This line here is 123. And we've got 11 minutes a little bit further up. So I take my parallel rules, I line them up with the meridian, and then I walk them up to 11 minutes, and then up to the parallel of latitude, which is right here, and that is my GPS fix right there. And so this would be labeled 1559 and G fix. I like doing this. It's fun because it just gives me a bit of an idea of how accurate I was. So right now I'm off by maybe 2/10 of a mile, so somewhere, it's maybe 600 feet actually. It's 1/10 of a mile that I'm out between the GPS fix and my LOP fix. And that's in spite of the fact that I had this big cocked hat and these two LOPs weren't that accurate. So let's see how I did on that one. So this one is 49 degrees, 17.7. So once again, this is the 18 degree latitude. So I'm going to go 17.7. So I'm going to go down 3 from 18 to 17.7. And then my longitude is 123, 13.7. So this line right here is 12. So I'm going to work my parallel rules. And you can see how they shift around. So they are there's a bit of a problem. So we're going to go to 13.7. So there's 13.5. I need to move them up a bit more. So 0.5, 0.6, 0.7 right there. And then I measure down from there, and there is my
GPS fix for 1629. So you can see how if I start labeling all of this stuff in here, it does start getting a bit messy. But all things considered, given that this is where I thought I would be with my LOP fixes using my hand-bearing compass, and this is where I actually was, following ship's compass here of 245 magnetic at a speed of 4 knots, and half an hour later, 2 miles along, there's my DR, which is where I should have been according to this information here. There's my LOP fix there, and there's my G fix. So you can see, as laborious as it is, once you do these a few times, especially if you confirm your fixes with the GPS, it can give you a lot of confidence if you ever need to do this because your GPS has failed and you have to rely entirely on your own, manual navigational methods. They do take practice. It is laborious, but it's worth it. I actually quite enjoy it. It's a fun exercise. I hope you enjoyed it, and good luck. I have recreated that exercise here so that you can clearly see what I was doing. I start with my first 3 LOP fix. Here you see the cocked hat and how the bearings on False Creek and Point Atkinson are almost reciprocal. Not an ideal situation. The 2 LOPs crossing at almost right angles are more accurate, as you will see in just a minute. I chose the center of the cocked hat as my position. If any part of the cocked hat was close to a hazard, I would choose that area as my fix. Having determined my position, I decide where I want to go and draw my line. I measure the bearing in true and convert to a compass bearing if I have a deviation table. Otherwise, I convert to magnetic. Based on my course and speed, I determine my DR position and label it with the semicircle and the time of 1629. I chose a half-hour interval, and at a speed of 4 knots, that means I should travel 2 miles down my course line in 30 minutes. I'm using round numbers here, so the math is easy. In part 2, I will be discussing how to calculate speed, time, and distance when the numbers don't work out so well. Having traveled for 30 minutes at 4 knots, steering as accurately as I could, I plotted another 3 LOP fix. The difference between the DR and the fix is the result of various factors, one of which is current. Determining course to steer to counteract current will be the subject of a future video. Now let's plot the G fixes and see how accurate my plotting was. You can see how the second LOP fix and G fix are much closer together, since my LOPs were crossing at ideal angles, resulting in greater accuracy. A little bit of practice will do wonders for your confidence should you ever experience some sort of digital failure and you find yourself having to rely on manual navigation techniques. New episodes go up every second Wednesday at 6 p.m. See you next time when I talk about my move from Vancouver to Campbell River on Vancouver Island. Thanks for watching. Until then, I wish you all fair winds and following seas.